Hello, hi everyone, welcome back to this channel, and here we are in the chapter 2 additional mathematics IGCSE, and we are about to learn about the sketching quadratic modulus graph. So this is the today's video. So in this sketching quadratic modulus graph, it's almost the same and almost similar method to sketching the quadratic graph. But you need to understand that when this y here is modulus, y cannot be negative value. So you need to reflect everything, you need to reflect all the graph here to the top, and you need to make x exist as a symmetry line. So you just imagine and just assume that the x-axis is the mirror line, and then you reflected everything to the top. That's the thing. You cannot have a negative y value. So it's the same method. So how do I know it's the same method here? It's just that you need to do the four component one by one. What's the first component? On this thing, we know that this is modulus, but we just consider this thing as a non-modulus first. So y equal to x squared minus 4x plus 3. So from here, you need to know what's the value of a. A equal to 1, b equal to negative 4, and c equal to 3. And then from here, you're just going to do the four component. What's the first component? A equal to 1. So it must be smiling. And then after that, the component number 2, y-intercept. So y-intercept equal to c value. And c value equal to 3. So know that the coordinate is 0, 3. We already identified that. That's the second component. Oh, this one need to go down here a little bit so that we have some space. Alright, now the third component is finding the x-intercept, but I always use it in the calculator. So use or refer back to the previous video. So refer back to the previous video how to find the x-intercept here, and then from here you press the value a equal to 1, b equal to negative 4, and c equal to 3. You're gonna get that the x-intercept is 3 and 1. Okay, so x equal to 3 and x equal to 1. That means the coordinate here is 3, 0, and here is 1, 0. Then we're done with x-intercept. And then after that, we need to know their minimum point. So this is actually smiling. So when smiling, we have a minimum point. What method that we use, which is h equal to negative b over 2a. So negative bracket, what is b? b equal to negative 4 over 2 multiplied by a equal to 1. So we have positive 4 here. Positive 4 divided by 2 is going to be positive 2. So this is the value of h. Alright, and now we need to find the value of k. How? By substituting h into the initial equation. So k equal to bracket 2x squared minus 4 multiplied by 2 plus 3 here. So we have 4 minus 8 plus 3. We have negative 1. Okay, so that's the thing that we're going to have here. So once we already have this is actually negative 1, you should know that this is a smiling shape, and then the coordinate here is 2 and negative 1. Right now, sketch everything like we want to sketch the quadratic graph first. Okay, of course we're gonna do it modulus, but we do it everything as like we want to sketch the quadratic graph first, the original. So plot down the 0, 3 y-intercept first. Okay, imagine that this is the value of 3 here. Just imagine that this is 3, and then we have the x-intercept of 1 and 3 here. Just imagine this is 1, this is 2, this is 3. So 1, 2, and 3. Alright, just imagine that thing, and we have a coordinate as usual. And the coordinate minimum point here, 2 and negative 1. So this is 2, imagine that this is negative 1. So it must be in this point. It must be pointed here. So your graph must be there. And then after that, your graph also must be here, must cross to this point. And then negative 1 here. Negative 1 supposed to be over here. But this one, I draw the x first. Okay? And then after that here, that it must also passes through this x-intercept. So initially it's supposed to be smiling. So if I draw the graph, initially it's supposed to be smiling. Okay, but this one I draw the dotted line. Okay, and smiling like that. Initially. Okay, initially. But like I said here, you cannot have a negative y value. Whatever things actually underneath the x-axis means that the y value is negative. So we cannot have that thing. So what you do here, just reflect it back to the top. This is negative 1, bracket here become 1. Even though the scale would not be correct, even though the scale is wrong, but make sure it's logical. Of course, when you reflect that thing, 1 still less than 3. If you reflected to the top and then one is higher than 3, that is illogical. So when you want to sketch it, it doesn't mind with the scaling. The most important thing here is actually logical sketching. So here the point must be at this, the maximum here when it reflected, it must be at this point, which is it must be happen at 2, 1 here. So now your graph would be curved like that. So that is how you draw the modulus graph. Please remember that. Always and always and always remember that. Okay, that is actually how do we sketch this modulus graph. So after we have learned about this modulus graph here, there must be a question and there must be something that related with this modulus graph here, which is about the number of solution. What can we understand about number of solution? Number of solution, it's actually the number of point intersection between the y-line and the graph. What does it mean by the graph? The graph is our curved graph here that we draw here. But what does it mean by the y-line? So here is going back to basics that you need to understand. What does it mean by y-line? So y-line here, it's for an example, y-line here need to understand that is the horizontal line. In the graph is the horizontal line, that it is parallel to x-axis. Your equation is y equal to what's the value? Like here is negative 1.5, so y equal to negative 1.5. That's the y-line. Okay, and on the other way around is the x line, which is the vertical line, which is parallel to y-axis. And example here, x equal to 3 because x passes 0.3 here. This is what it means by number of solution. So on these things here, they may ask you in this line, just imagine in this line, in this graph here, which and what kind of y line that have the number of solution of 2. So you can imagine here the number of solution that we may have 2 number of solution, it must be more than 1 here, because it must be y more than 1 here. Whatever there's actually more than 1, it can be y equal to 2, it can be y equal to 3, equal to 4 here. You can see that it only have 2, that's a 2 intersecting point. Yeah, only have 2 intersecting point. So you can understand if y is more than 1 of this maximum point here, number of solutions is going to have 2. Okay, so now you do understand how many number of solutions that we're going to have. How about if y is exactly at 1 here, y is exactly at 1, which is this line here. You're going to see there are 3 intersecting points. So which is this here is 3 solutions. So you need to understand. And less than 1 but more than 0 here, which is your y is less than 1 but more than 0, it's where the region that it must have 4 intersecting points. 1, 2, 3, 4. So that means between this thing have 4 solutions. And if y is actually equal to 0, it goes back with 2 solutions here, which is 2 intersecting points. So y equal to 0 is only have 2 solutions. It may look messy here, but I always tell my student, it is what it is. This is the thing that you need to understand. I'm here to explain. Alright, but of course in the real question they're not gonna ask you so many number of solution, so many condition of number of solution. Alright, but this is just actually explaining. So don't worry, let me go to the next example. For an example, this example. Alright, so let's go to this example. I try my best to draw as big as I can so that you are clear. So first of all here, expand this thing first and just don't look at the modulus first. Okay, just don't look at the modulus, just ignore the modulus first. So y equal to here, x multiplied by x is x squared, x multiplied by 1 is positive x, negative 7 multiplied by x is negative 7x, and here become minus 7. And you simplify x squared, 1 minus 7 is minus 6x and minus 7. So from here you do the 4 component, which is the first component here, a equal to 1. Yeah, this one of course you need to identify like a equal to 1, b equal to negative 6, and c equal to negative 7. Alright, so a equal to 1, it must be smiling. That's number 1. Number 2, y-intercept. Y-intercept equal to c value, and c value equal to negative 7. So it's supposed to be 0, negative 7. Okay? And then after that, the x-intercept. In the x-intercept here, need to press in the calculator. I'm going to use this calculator. So this calculator need to press mode 3 times, 1, 2, 3, find the equation here, and then press degree, press mode 1 more time to find degree equal to 2. A equal to 1, b equal to negative 6, and c equal to negative 7. Okay, so you're going to get the x value is 7 and negative 1. So x equal to 7 and x equal to negative 1. So that means the coordinate here is 7, 0, and here is negative 1, 0. You already identified that. And now we want to identify the minimum point because this is smiling. So h equal to negative b over 2a. If you don't understand what does it mean with an h here, refer back to my previous video talking about a vertex form. So negative bracket b is equal to negative 6 over 2 multiplied by 1, which is positive 6 divided by 2 equal to 3. Once you already know this, the minimum x coordinate is 3, now you need to find k here, which is substitute 3 back in the original equations. So it's going to be 3 squared minus 6 multiplied by 3 minus 7. So if you don't want to waste your time, you can straight away press in the calculator. So here 9 minus 18 minus 7 here, so negative 9 minus 7 here, it will be negative 16. And of course this one you can press in the calculator. So with that, these things here, with that k value that you already find, so it must be smiling, and the coordinate here is 3 and negative 16. So try to sketch everything and try to plot everything, but not draw yet. Okay, try to plot first. Alright, try to plot first. So maybe this thing is actually not that big, but don't worry. Alright, I'll try my best to draw as big as I can here. So first of all, it must be 0 and negative 7. Imagine that this is negative 7. Just imagine. Alright, negative 7, and then after that here it must be passes through of x intercept here, negative 1 and 7. Imagine that this is negative 1 and imagine this is 7. Just imagine. Alright, and we are sketching, so we are predicting everything. We just kind of like how do I say, it's actually predicting where the point is going to be and just estimate. Don't use the correct scale. Not to say don't use it, because if you are using with the right scale, you're gonna waste your time. Okay, and here just pointed this axis because this is modulus graph, the y cannot be negative. And then after that, the minimum point here happened at 3 and negative 16. So imagine that this is 3, just imagine this is 3 and negative 16. Negative 16 is imagined over here. So it must passes through to this point. Okay, alright, but since that we cannot have the minimum point, and we cannot have that the point here, it passes through the y, that cannot be negative, to reflect everything to the top. So when you reflect everything to the top, this is 7, negative 7. When you reflect it, it's going to be positive 7. Okay, and this is negative 16. When you reflect that thing, it's going to be positive 16. So you plotted the point where the line would passes through here, and also the point would be, the line would be passes through to this maximum point, something like that. Okay, all right, so now you already understand. So from here, draw your graph. First of all, it's supposed to be smiling, like I told you, it's supposed to be smiling. Alright, but then since that it's not smiling because the y cannot have a negative value, then you go back to the top here. Okay, alright, I may have some problem in drawing this thing in on the screen, but you can draw it nicely on your paper. Okay, so your graph would look like this. Can you draw this thing go higher? Can, no problem, that's not a big problem at all. Yeah, alright, if I draw it higher like that, it's gonna be something like this. So this is how we draw the modulus graph, and which region that could have 2, 3 and 4 number of solutions. So whatever things that is actually on top of 16 here, alright, whatever things actually higher than 16, when y is higher than 16, you're going to have only 2 number of solution, which is this example here, only have 2 number of solution. When y is more than 16, you only have 2 solutions, which is only have 2 interception. And then after that, when y is between this region, or maybe y is exactly at 16 here, when y is exactly at 16, you're going to have 3 solutions, 1, 2 and 3. So here we have 3 solutions. The region that have 4 solutions here is between these things here, between 16 and 0. So when y is less than 16 and more than 0, you're going to have 4 number of solutions because have 4 interception. Okay, so here we have 4 solutions. And where's the last possible value of y that could have two number of solution when y equal to 0 here? So when y equal to 0, you only have two solutions, because here and here. That's the thing. So I hope that this video can help you understand on how to draw the modulus graph, the quadratic modulus graph, and also how to understand about number of solutions. So if you find this video helpful, hit the like button and share and subscribe for more video. Alright, that's it for me. Thank you so much. We'll see you on the next video.